All right, so today we are going to do the fifth part of our notes. We've done 4 of them so far. We started on the first line doing median and centroid. Then we skipped to the third line doing angle, bisector, and incenter. Then we skipped down to the 5th line doing mid-segment. Then we went up to the second one and we did altitude and orthocenter. And now today we are on the 4th one. I know we skipped around, but we're on the 4th one, which is perpendicular bisectors and circumcenter. Okay? Not to be confused with anything else. And it's still Don't Shave December, so look at all these beards everywhere. No, I'm kidding. So, you should have written down row 4, and we are now looking at these notes. Perpendicular bisectors and circumcenters. So, let's get started. Notice under perpendicular, it says special segments intersect one side of the triangle at 90-degree angles. Okay, so that's what perpendicular means. Now we all know that, right? It makes 90-degree angles for perpendicular. And I see headphones in all my classes. I can guarantee it. So you should probably take out those headphones from our ears. I know I can record myself in the morning and know it's going to be true later. So, bisector means what? So a bisector means that something is cut in half, right? So the special segment also intersects the side at the midpoint. So when you see bisector, it's going to go through a midpoint. Okay? Now, if you make 3 perpendicular bisectors, you have created circumcenter. Okay? So, we have an important note right here. Perpendicular bisectors do not always intersect the opposite vertex of the triangle. Okay? So this is very important. They do not intersect the opposite vertex always. Okay? So, what do I mean by that? Look right here. Does everyone see this perpendicular bisector is dashed? Does it go through the vertex right there? Yes. Look at the one to the right of it. This is a perpendicular bisector, because of the tick marks. Does that go through this vertex? No. So sometimes yes, sometimes no. Right? So, it's very important. This is not the same thing as a median. Okay? And this is where all this stuff can get confusing. Week 1, day 1 of this unit, we talked about midpoint to vertex. That's called a median. We're not doing midpoint to vertex. We're doing midpoint that makes a right angle. Little different, right? So very important that the bisector does not always go through a vertex. Okay? Now this will remind us of orthocenter a little bit. 3 perpendicular bisectors intersect at the circumcenter. We knew that. We said that earlier. But it says right here, the circumcenter can be inside the triangle, outside the triangle, or on the triangle. Just like the last one we did. I know it's been a couple days. But when we talked about orthocenter, right? With orthocenter, it could be inside or outside or on, based on the altitudes. This time for circumcenter, using perpendicular bisectors, it can be inside, outside, and on. And it's going to be the same exact type of triangles. So acute is where? Inside, outside, or on? Inside. So if it's acute, the circumcenter is inside. If it's obtuse, where's the circumcenter? Outside. So again, that O, obtuse, outside, right? And then for the right triangle, it's going to be on the edge, okay? Now this time it's not at the vertex, but it's going to be at the midpoint of the hypotenuse, the longest side of a triangle. So again, acute triangle, circumcenter's inside, Obtuse triangle, circumcenter is outside. Right triangle, circumcenter is on the triangle. And then we have a theorem down here at the bottom. Okay, this is a little different than incenter, so I want everyone paying attention. There's a little distinction. Okay, so it says the circumcenter of a triangle is equidistant from the vertices. Okay, so if I'm looking at this, if you're looking at the video here, the colors on it, okay, these blue segments from the circumcenter, not to the edge, but to the vertices, to the corners, each of those is going to be congruent. So that's PA, PB, PC, they're all equal. Okay? That might be similar in your mind to incenter, but incenter was equal distance to the sides. This is not equal distance to the sides, it's equal distance to the vertices, the corners. Okay? So you got these in your notes. You know circumcenter has equal distance to every single corner. And if that's true, we can do some examples. So let's go ahead and flip it over. We're going to do 2 examples, and your assignment will be very similar to these 2 examples. So you want to make sure you're following along, taking good notes, right? Here we go. Practice problems. Segments KZ, LZ, and MZ are perpendicular bisectors of triangle GHJ. And all 3 of those segments are JZ's stepchildren. KZ, LZ, MZ. Alright, but seriously, so all these segments are perpendicular bisectors. Perpendicular means I make what type of angle? Right angle. Bisector means I'm going to use tick marks. Okay, so I'm going to label this. So if KZ is a perpendicular bisector, that means KZ is perpendicular bisector. Does everyone see how I did that? Perpendicular means right angle sign. Bisector means tick marks. Same thing for LZ. LZ is a perpendicular bisector. And then MZ is a perpendicular bisector. So if you know what perpendicular bisector means, you can label the perpendicular, you can label the bisector part. And now we can answer these questions. So HZ, okay, from H to Z. Now that's from the vertex to the circumcenter. What did we just say we know about the vertex to the circumcenter? Equal distance from the vertex, every vertex to the circumcenter. So do I know one of the vertex to circumcenter distances? I do. So if GZ is 19.9, GZ has to be equal to HZ and JZ. All right. So all of these have to be congruent, right? The whole Z family. It's a family reunion. All right, but seriously, if GZ is 19.9, HZ is 19.9. Because we know a circumcenter is equal distance to the vertices, the corners. So, GM. Y'all know how the Giants fired their GM. Haha. So, if I'm looking for GM, and I know MJ, rest in peace, is 14.5, then I know GM is also going to be 14.5 because they have the same tick marks. That's why it's important to label when we do these, okay? So GM, MJ, those are the same. They're 14.5. Now GK, now be careful with GK. GK is not 19.9. 19.9 is that, okay? But I know GK is 1 tick mark. What else is 1 tick mark? 18.6, okay? So be careful. GK is the same thing as KH because that's a midpoint. So they're both 18.6. Okay. And then JZ. Well, what does JZ equal? 19.9, because every one of those segments from the corner to the circumcenter is equal, from the vertices to the circumcenter. Okay? So if I gave you something similar to that, if you knew they were perpendicular bisectors, you'd do the exact same thing as that. Label stuff, figure out the missing parts. Okay? So you got one of those in your assignment today, you can do it. Number 2. Find the circumcenter of the triangle, RSO, with vertices -6, 0, 0, 4, and 0, 0. So let's plot these first of all. -6, 0, 0, 4, 0, 0. Okay? Now, to find the circumcenter, we need to do kind of like we did before. We need to find these 3 slopes, okay, from R to S and to O, okay? So I'm going to find, okay, let's find these slopes. So RS, the slope of RS is up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. 4 over 6 equals 2/3. SO is vertical, right? So that's undefined. And then RO is horizontal from left to right, so that's a 0 slope. Now, just like the last one we did, right? Just like orthocenter, we need to do perpendicular slopes. Okay? But this time we're going to do perpendicular at the midpoints. Okay? So, RS, 2 over 3. What is the opposite reciprocal of positive 2 over 3? -3 over 2. The opposite reciprocal of undefined is 0, and the opposite reciprocal of 0 is undefined. If you didn't know that, it's something you kind of got to memorize, is that 0 and undefined are opposite things, opposite reciprocal things. Now, here's the deal. We are not doing this at a vertex. We are doing these at a midpoint. Can't say that enough. That's what's different about circumcenter. So I want to find the midpoint of RS. So here's RS. To find the midpoint, halfway between 0 and 6 is 3. So 1, 2, 3, and go down. There's my midpoint. Okay? So the midpoint of RS is where I'm going to use the slope, -3 over 2. So down 3, 1, 2, 3, right 2, put a point, and then I can draw my perpendicular bisector. Okay? All right. Then I'm going to use 0 slope at the midpoint of SO. So let's find the midpoint of SO. SO is 4 units. Half of that is at 2. And a slope of 0 means it's going to be horizontal. So it's going to look like that. Last but not least, I'm going to do an undefined slope at the midpoint, if you can read that, midpoint of RO. RO is from 0 to -6. Half of that is 3. And now we're going to use our perpendicular slope of undefined straight up and down. And that's going to give me perpendicular bisector. If we extend it, we see that it crosses right there. And just because, like we said earlier, it's a right triangle, we know it's going to be on the edge, like we see there, at -3, +2. And that's circumcenter.